Hey, this is the video lesson for Algebra 2, Section 4.1, Quadratic Functions and Transformations. So the objective here is to identify and graph quadratic functions, which are parabolas. So here is another vintage lesson. The parent quadratic function is called x squared. So the f of x equals x squared is a parabola where the vertex is at the origin, 0, 0, and then the axis of symmetry, this is the vertical line that basically cuts the parabola in half, and if you folded it on this line, it would match up, so it's symmetric on this line, is at through x equals 0. So this is the parent function. And then all quadratic functions could be written, the line or the function could be written of this form, a times the parentheses x minus h, and this is squared. So fix that on your notes. This should be squared. I missed that when I made these notes like 10 years ago. And then x minus h squared in parentheses, and then this k is added on the outside. So this is called vertex form. So when you have a parabola in this form, the number being subtracted from x is your x coordinate of your vertex, and then the number that's being added after the squared is the y coordinate of the vertex. And then the axis of symmetry is always going to be a vertical line, so it's always x equals a number, and that number is the x coordinate of your vertex, so the h. So the axis of symmetry is always x equals h. So once you know the vertex, you know the axis of symmetry. All right, let's get to a problem here. Graphing a function. So when we're graphing a function, the way we learn to graph is to just use a table. And so if we have this function here, 1/2 x squared, let's make a table. I like to figure out what where the vertex is going to be, and then just do 2 to the left and 2 to the right. So in this case, this is vertex form, right? This is x minus 0 plus 0. The vertex is 0, 0. So it didn't really, we can just use 0 as the middle. So when I do the table, I do x, and then I go -2, -1, 0, 1, 2. And so we're going to plug that in. So my y is going to be 1/2 times -2 squared. This one's going to be 1/2 -1 squared, and so on. So then when we do that math, we get these points. So then we can do our graph. That's not very straight, but you guys can get it, right? And then we just plot these points. So we have -2, 2, and 2, 2. This, remember, is symmetric. -1, 1/2, and then 0, 0. And then once you have those points, you can just connect them in your nice little U, right? And there's the graph. So try this one on your own. If you need to go back and on the other example and press pause while you do this while you're on pause, go ahead and do that, and then check back for the solution. Okay, sorry, this one was a little bit annoying because you have fractions, but you guys are fine with fractions. This is our points, and so we have the vertex at 0, 0, and then 1 from each side goes down -1/3, and then 2 away from that goes down 4/3. And then you connect and this is an upside down U because of this negative. Okay, and this is what this kind of shows here. So how A affects this, right? Remember the A from the vertex form, a times x minus h squared plus k. This a is going to affect the sign is going to be whether it goes up or down, the u. So if a is positive, it's going to be a right side up u, a smile. And if a is negative, it's going to be a frown. It's going to be an upside down u. If a is greater than 0, it's going to be stretched, so it's going to get skinnier. And if a is between 0 and 1, right? Remember a negative just affects if it goes up or down. So a, we're going to treat, it's just the absolute value of a. If a is between 0 and 1, it's going to get compressed. So it's going to get a little bit fatter. Okay, and you can read about that down here. Okay, if a is greater than 1, right, it's going to be a u, and then it's going to have a minimum value because the vertex is going to be at the bottom of the u. So the minimum value of the parabola is going to be at the vertex. But if a is negative and it's an upside down u, that means the vertex is going to be a maximum. And so the y coordinate gives you the maximum value or the minimum value, which we will see in an example. Not quite yet, not here, but next time. Okay, so graphing translations of x squared. How do you graph each function? And how does each graph a translation of x squared? Well, here again, we'll do the table. So I'll press pause and write tables for these so you guys don't have to sit through me doing them. Okay, so I did this one and I took up all of the space on this. So maybe I'll draw it and then I'll erase it. Okay, here is our axis. And then we have -2, -1, which means 2 is also -1 because it's symmetric. 1 is -4 and -1 is -4, and then here we go. So here is our graph. Okay, and then the question also says, how is each graph a translation of x squared? Well, as you can see, x squared, the parent function, is just this one here. And all that happened is when it went down 5, right? And that's because of this -5. The number on the outside of the squared is the k. It just tells it how much the parabola goes up or down. So here, since it's a -5, it means it goes down 5. Okay, and so let me press pause and erase this and get B going. Okay, here's the table here I've plugged in. I knew the x-coordinate was going to be -1 because it's vertex form. Remember the number you're subtracting from x? So I made that my middle, and so I went -3, -2. And it doesn't really matter. It just makes your life easier. The math is easier if you do that. Okay, so let's plot these points. -3, 4. -2, 1, -1, 0, and then 0, 1, and then 1, 4. So there we go. Okay, and then how is each graph a translation? Well, you can see here, if we have our parent function, this has just moved left 1. And so that's because the number being subtracted from x is -1. So it's going left 1, right? And this was outside of the square. This was -5, so it's going down 5. This means it's going left 1. Okay, so try these two on your own. Press pause and then check back for the solution. I'll leave this. Okay, maybe you notice this is the same as that one up there. Sorry. So that just went left 1. And then this one just took your parent function and went up 3. So when you're doing these, you don't have to do the whole table if you know, oh, this is just going up 3. So just do your parent function, right? Your 0, 0, and then 1 squared is 1, 2 squared is 4, and then just flip it. And then just move every dot up 3 if you want. Okay, or you can do a table. But hopefully yours looked like this and just moved it up 3 and then left 1. Okay, moving on. So if we're interpreting vertex form, so when you have vertex form, here is an example. What are the vertex, axis of symmetry, maximum, minimum value, and the domain and range? So pay attention closely to this. This is definitely on the test. I think there's at least 2 of these on here, and it comes up a lot. And my students in the past have really struggled with this. So do this really slow and take your time to understand this, and it will really help you on your test. Okay, so the first thing we're going to start with is the vertex. So the vertex of vertex form is pretty easy. The hardest part is just you're going to see, this is the x and the y. And you're going to see this x minus 4, and you're going to want to write a -4, right? But remember, it's x minus h, so it's the number that's being subtracted from x, which is +4. So just always think opposite with x, opposite sign. And then just to confuse you, the y is just whatever's here, so it's -2. Okay, so that's the vertex. Just take your time on that to make sure you get the signs right. Okay, and then the axis of symmetry is always going to be a line that's vertical, so it's going to be x equals, and it's always going to be this x here, so it's 4. Okay, and then, so you need to figure out the maximum or minimum value. Remember, the maximum if the a is negative, and it's upside down, and it's a minimum if the a is positive, and it's a regular u. Okay, so you need to figure out, is my a negative or positive? In this case, it is +3, so this is going to be a u. I like to do that, and you can actually see it is a minimum. And then once you say it's a minimum, the minimum value, no matter what, the minimum or maximum value is always going to be this number. So y equals -2, or just -2. So this number is going to be your axis of symmetry. This number is going to be your minimum or maximum value. And to figure out if it's a minimum or a maximum, you have to find the sign of the a. Okay, and then domain of parabolas is always all real numbers. You can make this fancy r, or you can write all real numbers. Or you can write negative infinity to infinity. It's basically all x values, so all real numbers. I think this r with this extra line is the easiest. Okay, and so there will be other ones we look at that the domain is not all real numbers, but for this one, it's just always all real numbers. Okay, and then the range is going to be, right, all the x's from the minimum and up. So if it's a minimum, your range is going to start with your minimum value, so -2. And it's going to go all the way up to infinity. So you can write it it's going to include -2 and not include infinity. So this is your interval form. And you could also just say y is greater than or equal to -2. Either one is your range. Okay? And that is because, right, if you have a minimum at -2, right, the range is just the values of y that start here and go up. And so since this is -2, right, all the y values are going to be -2 is the minimum value, and it's going to go all the way up to infinity. Okay, here's one for you to try on your own. I'll leave this one up so you can press pause. Try this on your own and then check back for the solution. Okay, so here our vertex is -1. Remember, change the sign on the number that's next to the x. And then 4. And then axis of symmetry is always x equals whatever this x is, -1. And then you need to figure out if it's a maximum or minimum. Since this is negative, goes down. So that means we have a maximum, and that is at this number here, y equals 4. Domain, always this all real numbers. That means any x you can plug in and get an answer. And then the range is always going to be this number here, the maximum or the minimum. If it's a maximum, y is less than or equal to 4. If it's a minimum, it would be greater than or equal to 4, like this one up here. Okay, so make sure you take your time on these ones in practice. Okay, and so here's a summary of what we've learned so far. Translation of the parabola. If you have x minus h within the squared, right, that means it moves h units to the right. When you have x squared plus k, the number after the squared, that means it's going to go up k units, right? And if this is positive, it would move left. If this is negative, it would move down. And so when you have both, right, it moves both horizontally and vertically. So in this case, it would move right h and up k. So that's why that's the vertex. So it starts at 0, moves right h, up k. Okay, so how are we using vertex form? So what is the graph of this function? We can make our axes and then find the vertex. The vertex here, remember, is going to be the number being subtracted from x, so 1. The opposite of -1 is 1, and then this one is 3. Okay, so we'll go to 1, 3, and put our vertex there. And now we will plot and remember this axis of symmetry is x equals 1, so that means our parabola is going to go through here. It's negative here, -2, so it's going to be going down. And then we can just plug in a point or two. Let's try x equals 3 and plug in 3. -2 times 3 minus 1 squared plus 3 is going to be -2 times 2 squared plus 3. -2 times 4 plus 3 is -8 plus 3 equals -5. So here we're going to go down 5. 1, 2, 3, 4, 5, and we have this point here. So that means our parabola is going to look like this, right? And because this is the axis of symmetry, we can just reflect this point. It's 2 away from the axis of symmetry, so we're going to have another point that's 2 away the other way, right there. And we just reflect it. That is really bad here. And there's our graph. Okay, so try that one on your own, and then you'll have practice, and then we're done. All right, so press pause, do this one on your own, and then check back for the solution. Okay, so here we have this graph. It took me a couple tries to make it a U. Make sure you don't make a V, because that's absolute value, so you'll get points taken off. Make sure it's a U. So this is pretty steep. Anyway, the vertex is -2. Remember, change the sign there, and -5. So plot that point there. And then your axis of symmetry is that's a negative. A -2 here, and then so make your vertical line so you know right through that vertex, and then find one other point. So in this case, I just so this was at -2. I thought 0 was a good one, so I plugged in 0, and got 3. So then when x is 0, y is 3 up here. And then I just made a smooth U there, and then I could reflect. So this point gets reflected. It's 2 away from the axis of symmetry that way, so you go 2 the other way and make your point, and then you can make your U, and that's the graph. So time for practice. Enjoy.